Hello everyone, let's continue our course. This chapter, let's first see about encapsulation process of TCP IP. First, the user data. In previous chapter, we have learned the user data will encapsulate in TCP and in IP, and then encapsulate in a frame. So today we will talk about TCP header and what's exactly in the IP header, the detailed information. First is about TCP segment. TCP header is before the user data. It's about 20 byte to 60 byte long. This is the detailed information. First is the source port. TCP use port number to describe which interface to which application interface connect to which application interface. Source port and destination port. It both has 16-bit long. And then it's the segment sequence number and acknowledge number. They are same length, 32 bits. The sequence number and acknowledge number is used by the TCP session. If one side sending a packet use this sequence number, sending a segment by this sequence number, another side need to acknowledge this sequence. That means the other side received successfully. Okay, and then the left part can be the other options. Next is the IP packet. IP packet is before the TCP header, and IP packet, all of this information is useful. The typical length of IP packet header will be 20 byte. First, let's see about this version. This version information can be IPv6 or IPv4. Nowadays, we use IPv4. Message length is about this header length. And then service type. Service type describes which type of service is this packet belong. Is that a VIP service or a normal service? We use this one to identify the different level of service. Total length is about all this packet length. Identification. Each IP packet has different identification number. Flag and chip offside. If this packet is very large, the interface cannot forwarding this big packet. It will cause some problem. Next page, I will talk about it. And then the source IP address, destination IP address. We use this IP to find the next hop, to find the destination. This IP options is optional. Okay, back to our question. If this packet is very large, bigger than the interface MTU, what will happen? So the fragment is needed. Okay, let's see about this example. One packet arrived from this PC to this router. The router have the MTU. MTU length is about like this size. This is MTU. So this packet is bigger than this MTU. Each time it can forwarding the traffic like this size, and smaller, but cannot bigger. It will forwarding one by one the fragment packet. After they arrive to the destination, this router will receiving the fragment and rebuild the totally packet. After this packet recovered, it then forwarding to the host. This is the fragment. It is called issue of IP fragment. If this packet is bigger than the MTU, it will fragment, and after forwarding to destination, build together back to the originate packet. Ethernet frame. The user data, TCP, and IP. Then the Ethernet header, and also the Ethernet trailer. In Ethernet header, we have this information: destination MAC, source MAC, and this is called length type value. In this layer, the Ethernet, we have two standards. The first one is Ethernet 2 standard, and then is 802.3 standard. These two standards also used in our network. Typically, we use the Ethernet 2, and this length type value have this meaning. If this value is bigger than 1500, the meaning is represent type. It means the type. If it is smaller or equal to this value, it represents the length. In this chapter, we have learned TCP segment structure, IP packet structure, and Ethernet frame structure. They will encapsulate the user data one by one. Here is the question. If the packet length is larger than MTU, what is needed? Okay, here is the issue. We know if the packet is too big, it cannot forwarding at one time. It needs to cut into smaller pieces. This is called the fragment. It's called fragment. That's all for this chapter. Thanks for watching.